What's up, everybody? I want to do a quick overview of the lab that I designed for Cisco Live and just kind of go through some of the features and capabilities and things you can do with it. It's a very extensive topology. I have some diagrams. They are located on the main page, kind of shows the physical topology, which matches what is in the CML lab, which if I pull it up here and blow it up, you can see we've got this host out here. If we go back and we look at the topology folder, we've got images that show all the addressing. So all of this matches what is in CML. I did find an issue with the YAML. I've updated it where the IP here was not set. It didn't get fetched from the ASA node for some reason. So I've updated that. The hosts here, I had them set incorrectly. They were set as a ::10, and I actually didn't set the IP as part of the startup process. So now when you open the host up, they will automatically configure the IPv6 address that they're supposed to be using. This will match what is in NSLOOKUP if you use the DNS server here in the system. If we go back, you can also look at the protocols. So this shows the IPsec tunnel running between the firewalls, the IP addresses that they connect on internally, and then what is allowed to transit. These hosts have to use the firewall to get out to the internet. So for any kind of pings to Google's like DNS or whatever, they have to go out through this firewall. You will see them transit over the IPsec tunnel if you bring up ASDM, which we'll talk about in a second. And then, if the IPsec's not running, they're not going to get out. Like that is the only way for them to get out the internet. We have VXLAN running here. I'll do a quick demo to kind of show you some stuff there. There is a quick note in the configuration. The NVE interfaces, which actually establish the peer relationships between the different VTEPs, by default do not start up. And they actually, they're enabled, they're running, but they don't actually form the peer relationships. There's two ways to fix this. I put this in the document. You need to restart the NVE interfaces. It's just opening up the console, going to the leaf switches, leaf 1, 2, 3, and the border, and running this interface NVE shut, no shut. But if you want to get your hands on some automation, you want to kind of play with the automation, there is a playbook in here. I put instructions in there, but this shows you what a healthy environment would look like. If you were to just run this show NVE peers command, which is what this is actually doing, you would see nothing. Basically, this Ansible script fixes that problem. If we go look at restart NVE, it just runs through, it hits all the nodes, the inventory is set up, all you need to do is run it. But it does a shut, does a no shut, runs the show NVE peers to see that they've actually produced some details, and then it runs it again to verify that we've got data. So we just want to see that things are working and we're ready to go. Go back and we can look at one of these hosts. So if we bring this up just to show you the VXLAN fabric stuff, so you can see this is pinging. If I were to pull up one of these links, let's just try this one. So if we look, we can see there is an ICMP occurring here, and it's going over to that 210 host. And you can see the tagging. So if you run packet captures, you can see the VXLAN encapsulation. You can see the VNI it's using. That is for L2 VNI. So this is layer 2 communication within a VXLAN fabric. And then on this host, if we do console, this should be trying to ping out the internet. So you can see it's going out to Google. If I just try do a different address, do 8844. If we look at packet capture again, start it, see if we get an ICMP here. You can see, again, it's encapsulated in VXLAN, but if we look at the VNI, it's using 200, which, as I've noted here, is the L3 VNI. That is so it can route out to the border host here, which connects it to the edge router, which does NAT. If we look at packet capture here, you can see we're getting packets with the internal source address of 172.17.110. We're going to 844. And if we look here, we do start. We can see it's being translated to the NAT address, which is the overloaded IP that is set on the outside interface going out to the internet NAT. That IP address comes from the NAT external connector. It gets out to the internet, comes back in, sends it back to the host. So you can see we're getting some real internet connectivity here. You can do wgets out to things like CiscoLive.com, which I demonstrated in the session. There's full routing here. This is doing IPv4 and v6. These hosts here, if we do a console, so this host is also pinging Google. But if I do a ping, we can do this 24A address just to show that IPv6 is working. I have ICMP enabled everywhere. Let's see if that actually starts pinging. And there it goes. So it's starting to ping now. I can reach the host, but what I can't do, and if I do an SSH here, I'm not going to be able to get access to it. And if I go to the console here and I open it and I do show logging ASDM, you'll see we're getting denied TCP from this source here to this destination. And that's because I didn't enable TCP for IPv6. I kind of left a lot of this IPv6 stuff configured just so that we could show reachability. But if you want to go in and do some configurations of your own, if you want to set access lists, you can do that with ASDM, which I have running here. We can see one of the hosts here. If I go add another device, I need to figure out what the IP is first before I commit to that. I click on host and I go to, so it's going to be, should be this outside address. Copy that, come back. Hopefully I'm right here. Okay, and so it's connecting. It's going to be admin secret password. Everything in here is admin secret password. It's going to say there's no license installed. Yep, but you're rate limited, so don't try to do anything crazy here. If you do have a ASAV license and you put it on here, it will open it up to full access, full throughput, and you can move some data through here. But if you try to do it with the 100 kilobits, it's slow. It's very, very slow. But we should be able to bring up this ASDM now. We can see there's a ton of stuff in here. And if I go back to this host here, try to SSH, and then bring up my ASDM, we can see those logs are appearing in the ASDM syslog messages. So two ways to look at it. There are instructions on how to set up the proxy, which is running on the Ubuntu Services host in the GitHub repo. By default, the allow local net access, this line here, is not enabled. When you first get it set up, you need to disable, you need to uncomment it and then allow it to enable, and then restart Squid. That will allow you to set up proxy, whether you use the browser or whatever, which will let you get to the ASDM installer. So if I do proxy here, it's very simple. We do proxy, settings. I'm going to set my manual proxy configuration. And I'm just going to go 10.255.255.50, which is the host. And you see we're getting into the ASDM that's running inside CML. You can do install ASDM launcher. The other thing I want to point out is, and I need to turn the proxy off before I do that. No proxy. For ASDM access, if you're using a Mac, it's very simple. You just need to set your network interface proxy, the secure web proxy, to whatever IP you set up in CML, whatever your Ubuntu Services external IP is. For Windows, it was a little more complex. You actually have to edit the run.bat, which is located in program files, Cisco Systems ASDM. By default, this is the line. This is what's there, just so you can kind of figure out which line it is. There's only a little bit of data in there. But you need to add this proxy host and proxy port. For some reason, I don't know why the system proxy settings, if you set it up in the the browser or you set it up with the network, it doesn't take it. So you actually have to go in and edit this file. The final output basically is going to look like the above with these 2 lines in it. You just need to change your IP to match whatever you set your stuff up with, and it'll run. I'm running this on Windows right now. If you actually do ASDM, if you look at the console, once you've done that, you can just do S, which will dump the properties. And what you should see is your proxy set up in Java. I don't use Java for anything else, but for playing around with the ASDM. But you want to see this proxy host or it will not connect to anything inside CML. So that's a quick overview. Again, this lab has so much capability in it. We've got OSPF v3, OSPF v2 in the VXLAN fabric. We've got BGP, IPv4, v6. We've got NAT. There's DNS, NTP running here. Lots of things to play around with. I argue that this represents very similarly to something you'd find in a production environment, at least from the types of things you'd run into in a production environment. The way things are configured, the core here, you could modify this core to become a segment routed network. It could run MPLS. The sky's kind of the limit. Maybe use this as a framework for starting your next project. And if you want to try automation, I've given a little bit of automation with the Ansible playbooks. There's also some documentation on some setup that you have to do. But have fun with this. Play around with it, break it, see what you can do with it, and then it's running a full 20 nodes. You could pull some things out if you want and put some different nodes in. But yeah, definitely, play around with it. It's yours to do whatever you want with. And if you have any comments or feedback, leave them in the comments, leave them in my GitHub, and just, let me know what you think. Appreciate everybody who came out to the Cisco Live session. For everybody who's watching this after the fact, thanks for checking out the lab. Let me know, your thoughts, and I appreciate everybody who watched my video. We hit 500 subscribers, and I'm super excited to keep sharing more things with you. So everybody, have fun with this, and thanks for watching.